Hi, this is Chrisferb, and I'm going to be reviewing the one-way Anova calculation in Excel. That's one-way analysis of variance in Excel. I'm using a pretty new version of Excel, so I have the ribbon up here. I don't know how far back the data analysis tool pack goes in Excel, but I'm assuming this goes back at least a couple versions in Excel. So you would think that to do the Anova calculation, you would think it would be in formulas with statistics, and that's where you pretty much go to look when you start off looking for this. But it's actually in the data tab in the ribbon and the data analysis tool pack, which is way over here on the right hand side. If you don't have the data analysis tool pack enabled on the data tab, then you need to go to File and go to Backstage. This is the Backstage area. Click on Options and go to Add-ins, and you want to enable the Excel data analysis tool pack, and that's in Add-ins from the back page. So once it's enabled, you'll see data analysis, and then we can get started. So I'm going to click data analysis. Anova single factor, that's what we're looking for, because it's one-way Anova or single factor. People use both terms. So we have our little window pane over of what we're going to select for it. So I'm going to select my data. Now you can either select your data with the labels or without the labels. It doesn't matter, but you just need to make one small adjustment when you do. So I selected with the labels over the top of the columns. Also, our data is grouped by columns. So method 1, method 2, method 3, so it's in columns. You can do rows if the labels are on, say, the left-hand side and the data goes left to right. So I have the checkbox for the labels in first row marked because I ended up selecting those. And our alpha is 0.05. So that's our significance level is 0.05. It's very common to do 0.05, but in Excel you can change that if you need to. For the output range, I'm going to select, it's actually just one cell you select. When it says range, it kind of fools you, but just select the one cell that you want it to be in, and it will, the output will be a range, but it starts in this one cell, upper corner. I'm going to hit OK, and now it calculates it. The top part is a very basic calculation of our data. It's the second part that I would say is the most significant for what we're working with here. It makes an Anova table similar to what you would make doing the calculation by hand. The sum of squares, degrees of freedom, the mean squares, our F statistic, our p-value, and our critical value. It's these three right here that are the most important for us for making a decision. Our critical value is our calculated statistic, which is about 3.85. Our p-value we'll use later to make our decision, but for right now we can look at the F critical value, which is the value where if our calculated statistic is higher than or equal to our F critical value, then we reject HO, because what it means is if this our calculated statistic is actually more than 5.14, then our calculated statistic is in what we call the rejection zone. In this case it's not, it's below the critical value. So we just by looking at this, we know that we are not going to reject HO, which means the data is not significantly different than what we expected. I have another tab where I have a little bit more description of our decision process. So here's the F critical value. It's this line right here. So that's the 5.14 that I was talking about. And then the calculated F value, which is 3.86. So you see our calculated value is not in the rejection zone. The other thing I have listed is the alpha, or the level of significance, and then our p-value, which is our calculated p-value, and our our alpha is less than our calculated p-value, and when our alpha is less than our calculated p-value, we do not reject HO. So in this case, we're not going to reject HO, which means the data is not significantly different. And that is how you do the Anova in Excel.